Hello, this video is titled Sizer, Beam, and Column Mode Overview. For those of you who are unfamiliar with the Design Office suite, it consists of three separate programs: Sizer, Connections, and Shear Walls. Sizer can be utilized to complete gravity load design. Connections can be utilized to complete the design of the typical fasteners included in the NDS and the CSA OD6, and Shear Walls, which is a lateral load design tool. This video will go through the beam and column modes of the Sizer program. Within Sizer, there are three separate modes: Concept, Beam, and Column Mode. Concept mode can be utilized to create a gravity load model of your structure up to 6 stories in height. You can specify columns, walls, beams, and floor joists, add point loads, area loads, or line loads. Sizer will automatically distribute these loads between members and down the structure using the tributary area method. Concept mode will create preliminary design results, which you can refine further in beam or column mode. Members can be transferred directly from concept mode into beam or column mode, or alternatively, if you want to complete the design of a single beam or column member, you can navigate directly to beam and column mode and design the member there. This is exactly what this video is going to go over. If you want a demonstration of Sizer's concept mode, there is another video linked in the comments. Just a reminder that for key codes and sales related questions to please contact sales@woodworks-software.com. For technical questions related to the software, please email support@woodworks-software.com. These emails and information can be found in the help menu of all the Design Office programs under the About WoodWorks icon. Just a quick outline of this presentation. I'm going to start by doing a demonstration of Sizer's beam mode using the Canadian edition, and then I'm going to demonstrate column mode using the US edition. The inputs and interface for both programs are almost exactly the same, so this video is catered towards both US and Canadian users. Alright, so once you've entered the program, you're going to be brought to the welcome screen, which we'll press OK to. As mentioned before, there's the three options: concept, column, or beam mode. For this example, we're going right into beam mode. One of the common questions in the Canadian edition is how to switch from metric to imperial units. So to do that, you would click on the Settings tab, go to Format, and change the unit system to imperial. So now we're in imperial units, and we'll just move forward with imperial units for this example. So the first step is to add a span length. So I'm going to start by adding a 10-foot span. You have the option of adding up to 6 spans in Sizer. Once you add an additional span, the options for cantilevers will become available. You can specify a cantilever on the other side of the member. But for this example, we're only going to do a single span. The next step is whether or not how you want to distinguish your span type, and there are three options: design, clear, or full span. So clear span means that the 10-foot span you specify is going to be measured between points of bearing. So you can see the 10-foot falls between the points of bearing in the diagram. To change to full span, that means the points of bearing are going to be included within the length of the beam. So now you can see the length has changed up here. And then there's design span, which means that the length of 10 feet is going to be measured between the center of points of bearing. So if you leave unknowns within the bearing design, ultimately the length of the member is going to change when you run the design. In any case, we're going to leave it as design span for this example. The next step is to decide on the type of member. So you can pick between a beam, floor joist, or roof joist. The difference between floor and roof joists is the live loads associated with them. There are lower requirements for live loads on roofs than for floor joists. For this example, we're going to design a simple floor joist system. So you'll see that right away the material is pre-populated for you, but you have a whole list of various materials, including some SCL products. But for our example, we're just going to stick with common dimensional lumber. And we'll go with the SPF species group and number 1, number 2 grade. So when it comes to the width and depth, You could leave it as unknown and let the software pick a width and depth for you. We're going to at least specify a width of 2, but we'll leave the depth as unknown and let a sizer decide what the appropriate depth should be based on the span. Joist spacing becomes available when you select floor joist. We're just going to keep it at the typical 16 inches on center. And case 1, case 2 load sharing. Case 2 load sharing is appropriate for floor joist systems with sheathing on top. These sorts of design assumptions for load sharing you would have to become familiar with from the CSA 086 or the NDS 2015. To the right here we have deflection requirements. These are pre-populated for you, but you could modify them if you desired. If you did have a service condition such as wet, or if you had a treatment applied to the members, you could specify that here in the modification factors. Down here is your lateral support spacing. So by default for floor joist, the full lateral support will be provided along the top of the member and no lateral support along the bottom. But you can change this depending on your configuration. Floor vibration. This is only available in the Canadian edition. Since we have vibration criteria. This comes from Part 9 of the National Building Code, and so this isn't available in the US, but you can obviously modify these details to whatever thickness of floor you may have. So in this case we'll change our floor sheathing thickness to 3/4 of an inch, but we'll keep the other information as is. Glue fire design. This becomes available if you have a glue member. Now over here is your supports for bearing and notch design. So you have the choice of specifying the bearing, what material the beam will be bearing on. So by default it's a beam, but we're going to change this to a wall that consists of, once again, lumber, SBF, number 1, number 2. So now instead of I have a floor joist that's bearing on top of 2 double top wall plates. When it comes to the length of bearing, you can leave it as unknown or pre-populate it with a specified length. These are pre-populated. These options are pre-populated for you. So we're going to go with a 3.5 inch wide bearing length. Down here you could add a notch details if you desire at the top or bottom of the beam, but we're not going to do that for this particular example. So now that most of the information is filled in the beam input, we're going to move forward to the load input view. So the first step is to add a load. So you need to put in a magnitude. So for this example, we're going to just put in a typical 10 pounds per square foot dead load and a typical 40 pounds per square foot live load. Ultimately, you could apply different load distribution types, triangular loads, point loads, applied moments, whatever you like along any part of the beam. Typical floor joist system typically are designed for 10 PSF dead and 40 PSF live, so we'll just leave it as with these 2 loads for now. Over here you can pick your importance factor associated with it. This will just be a normal importance for a typical floor joist system. And then here you have the option of including the self weight of the member in the design or turning it off. So we're just going to automatically include it, which is the default setting. Don't have any moving point loads, and we don't have to use these other options. If you want to save your typical load case like this for future files, you could save this as a default load so that you don't have to pre-populate this the next time you come in. So points of interest. So points of interest is a useful tool. It allows, if you were to add a point of interest, say at 2 feet and 8 feet, what will happen is when you run the design and look at the diagrams, the software is going to report the shear and moments at these 2 points of interest that I've specified. And we'll show you that when we after we run the design. So now that we've done all that, we can run the design. And this is the design summary. If you leave unknowns, the software is going to produce a design summary where you would then need to pick what section to use. So in this case, it's an SBF number 1, number 2, 2x8 is the solution. But if you had left more unknowns, such as the species and more grades, then you probably would have had a longer list of available sections that would work. So now we'll click on the section that's been produced for us, and now you're in the design summary. If you didn't leave any unknowns, you would have been brought directly to the design summary when running the design of the member. So we'll just go through the design summary quickly. You have the design check calculation sheet. Here's a nice summary of the loads that were input, as well as the self-weight of the member. Go down a little bit more. You have the detailed bearing design summary. So yeah, you start off with your unfactored dead and live loads, what the factored load would be, and the bearing resistance of the joist, as well as the support. And we're showing the various analysis versus load results per here. So we can see that we're way over capacity for the length of bearing. Down here you can see that the minimum length of bearing is 0.57 inches, which is way less than the 3.5 that I've specified. So for bearing, we are more than adequate for the design. The other details that are over here include all the various factors that were used in the calculation for bearing, so you can check these calculations over here. If you think this is too much information, you can always go to the Settings tab, and under Preferences, you can opt to not include the detailed bearing design results in your design. But I like this information, so I'm going to leave it as is. Below that, there's a summary of the material that was designed, giving you the information on the floor joist spacing, the volume of the member. In the case of the Canadian edition, we have floor vibration criteria. You can see the details I'd specified are listed here. And if you scroll down a little bit more, this is really the area you'll want to be checking when looking at the results of the member you've specified in the applied loads, really to make sure that all these analysis versus design ratios are all less than or equal to 1. You can see the shear moment and all the various deflection checks are reported for you, as well as their ratios. In the case of this member, it was actually governed by the vibration criteria, as with most floor joist systems in Part 9 of the Canadian National Building Code. And you can see the ratio is about 0.7. Below that, you have the additional data, which is essentially all the information that was used to calculate the various shear moment and deflections of the member, and all the various factors used with those calculations. And you could use this information to back calculate the moment resistance or shear resistance of the member, as well as the deflections. Below that, we have the critical load combinations. For each one of those calculations, we're reporting what was the governing load case, as it does change. So you can see the deflection of permanent dead load was just 1 dead, but the other 2 deflection checks, it was 1.0 dead plus 1.0 live. As well, points of bearing, reporting what the worst case load cases were. And then below that, you have some additional calculation information, such as the stiffness of the member, and as well as important design notes associated with running the design. So we'll keep working our way across here. The next one is the analysis results. This is where we report all the various load cases that were checked for this particular design. All right, the next one is the view diagrams. By default, we show the critical case, but you can navigate between the various load cases which were checked here. You can see that the points of interest that I specified at 2 and 8 feet, that the shear and moment are both reported for you here. Okay, now for a overview of column mode using the US version of the software. So just like in previous demonstration, but I'm going to go into column mode. Again, to start things off, you need to input a height of the column. So for this case, I'm going to go with a 9-foot high column. You have the choice of picking either a column or a wall stud. For this example, we'll go with the typical column. And then you move on to the material. You have your choice of all the common ones from the NDS, or you can pick Nordic products here. For this one, I'm going to go with a timber soft column. And for the species, I'm going to go with Douglas Fir North. Number 2 grade, make it number 2 grade. And I'm going to leave the width and depth as unknown and allow the software to calculate this for me. Below here you can add your modification factors. If you had a glue limb, there's some combinations of things you need to do related to the stress class and the combination. And up here, if you did have a built-up member, this is where you specify the number of plies and the type of connection, which is going to affect the capacity. As well, these deflection limits, these are pre-populated for you, but you can modify them if you deem that is suitable. If it was a repetitive member, you could specify that here, or if you have a fire retardant factor or incising factor. As well, the temperature factor associated with members. This is just going to be a simple member inside, so we're just going to leave everything as is and go with the default settings. Scroll down a little bit more. You have your lateral support spacing or unbraced length. Here you could specify that maybe you have lateral support at 4.5 feet. Okay, and now for a demonstration of column mode using the US edition of the software. So just like we did earlier, but this time we're going to go into column mode. Once again, to start off, you need to input a height. This particular example, I'm going to go with a 9-foot high column. You have the choice of either specifying a column or a wall stud as the member. For the purpose of this example, we'll pick a column. Next is the material. You have your choice of all the common materials from the NDS or some Nordic Land products, but I'm going to just go with a typical TimberSoft column for this example. Next is the species. For this example, we'll go with Douglas Fir North. I'm going to leave the grade as unknown, as well as the width and depth. That way the software will iterate to a solution and suggest some sections for me based on the applied loads. Up here you have your built-up member. If you did have a built-up member, the number of plies will become available, and as well as the connection type. For glue limb products, there's a number of other options for specifying various stress grades. Right here you have your deflection limits. These are pre-populated for you based on the type of member you specified. Scroll down a little more, you see the modification factors for temperature, service conditions, repetitive member factor, incising factor. We're just going to leave all these as is and go with a typical dry service condition member. Lateral support spacing. Here you have, by default for columns, it's unbraced about both edges. But if you want, or if this was a column embedded in, say, concrete or something along those lines, and you felt that you could have different end conditions, you could go with a fixed pinned or fixed free. We're just going to stick with the typical pin-pin connections for that is typically used for wood column design. If you did have, say, a support spacing halfway up the member, you could specify the exact length. So in this particular case, you could go 54 inches. You can see that along the depth of the member here, we now have lateral bracing. But for this particular member, we're just going to go with unbraced conditions. Down here you have your fire design. For this particular member, we're going to say it's exposed on all four sides. Then I want to have a 1 hour duration fire design, and I'm not going to add any protection around it to increase its fire resistance. And I want to calculate these calculations using the NDS Chapter 16. For support for bearing, you could specify, by default the type is specified as non-wood, but you could specify a sill plate or a beam. For this one I'm just going to stick with non-wood. Next you move on to your load input. So for this particular example, I'm going to add a 10,000 pound dead load, a 20,000 pound live load, a 25,000 pound snow load, and then I'm going to add wind load consisting of a full uniform line that has a magnitude of 20 PLF, so that we can get some combined loading checks. Currently you can only specify the combined loading about one face, either the width or depth of the column. I'm just going to leave it as the width, but if you did modify it to the depth, it would complete calculations based on the depth of the column. Once again, your self-weight, we're going to leave that as included. And I've also decided to apply the auto-eccentricity specified in the design settings. Long-term deflection, you can choose whether to use NDS 5.2, or you can go with a different option such as the IBC deflection factors from table 1604.3. And I'll leave it with the IBC method. So now that you've input some load and you specified some details, we can run the design. So it's taking a little longer to run the design because it was iterating through the various solutions. So for this particular column, it's this is the design summary, and you can see here that one suggested section has been suggested, but two different grades. So for this one, a number 1 or number 2, or select structural 10 by 12 would work. So I'll go with the number 1. So once again, the design results very similar to beam mode. You have a summary of all the loads that were input. You have the lateral reactions and a summary of the unfactored loads and the loads. If you did have some bearing material specified, there would be additional bearing design criteria, but here we're just checking the crushing of the bottom of the member. Summary of the member: timber soft, Douglas fir north, number 1, 10 by 12. The actual dimensions listed here again. Support is non-wood, total length of the member, volume of the member, end conditions, whether or not it's pinned at the base, and what lateral support calculations are used, as well as its fire design. So if we scroll down a little bit more, we can have we can look at all the various criteria. So shear, bending, axial, combined, loads, axial bearing, live, deflection, total deflection. And as well, we can see here that the fire design, combined axial and eccentric moment, is actually governing the design for this case. And that's because it's pretty stringent to have a 1-hour fire design for a solid sawn member. So it really needs to be oversized to be able to last 1 hour in the event of a fire. So you can see that this is actually governing the design. Below that, you have your additional data, all the various factors used in all the calculations, as well as all the C factors applied for the engineered design. Again, critical load combinations are listed for each and every single one of these calculations. And then you have a number of other information provided for the fire design, as well as the fire design adjustment factors and residual section at the event of the end of the fire, and then some design notes. Again, you can go and look at all the various load cases in the analysis results. Here you can see that there are 13 load cases that were checked for this particular member. And if you wanted to, you could go and review the shear, bending, and deflection diagrams for this particular member. Well, if you have any questions or need any help with the software, you can always go check out our user guide on the website. And thanks for listening.